Flip your stainless pan over, and you will see it right there on the bottom, 1810. You probably paid extra for that stamp because you thought it meant a real alloy and a real recipe, not just a vibe printed on a box. So I'm going to do 3 things for you today. I will tell you what 1810 used to mean, what it actually means now, and how the swap happens without you ever noticing. Because the real question is simple. If nobody is checking the metal, who exactly is keeping the stamp honest? The stakes show up as pits, rust freckles, and metal moving into your food when you cook acidic stuff. And that is exactly what we are going to look at. Back when 1810 actually meant something, it was shorthand for a specific stainless recipe that you could rely on. The numbers represent roughly 18% chromium, which forms a protective film to slow down rust, and about 10% nickel to keep the structure tough. That nickel is what helps the steel hold up when you hit it with heavy doses of salt and acid. In the supply world, those numbers usually point you toward the common food contact grade called Type 304, which is the default stainless you see in restaurant kitchens because it survives constant abuse. The problem is that the 1810 mark on cookware in the United States is not a federally verified grade, but rather an industry term that rides entirely on trust and paperwork. Almost nobody in the retail chain has a reason to test the metal, which means there is no routine alloy testing at the ports, and no inspector walking the warehouse to pull random pans. The pan shows up at the store, the box says 1810, the stamp says 1810, and the retailer moves units without ever knowing what is inside the steel. Now you have to look at the incentive for the manufacturer to cut corners. Nickel costs real money, and the pricing moves around constantly. So when a buyer asks a factory for a cheaper pan that still looks premium on a shelf, the easiest place to cut costs is inside the alloy where you cannot see it. This is where Type 201 enters the chat. Type 201 is still stainless steel, and it still shines and polishes up perfectly for the marketing photos you see online. It still feels like heavy stainless in your hand. And since both 201 and 304 live in the same austenitic family, you do not get an obvious giveaway like one being magnetic while the other is not. What actually changes is the ingredient list, because 201 runs with less nickel and more manganese, and it often carries much higher carbon limits than the 304 you were expecting. From a metallurgical standpoint, that trade usually results in a weaker passive film and more chances for localized corrosion to start. This is especially true when you are re-wetting the surface with salty water, heating it up, hitting it with acids, and then letting it sit to dry. Manganese can show up in inclusions that become the first weak points. And those are the exact spots where tiny pits like to start once chlorides and acids get enough time on the metal. That is why the phase where your stainless looks fine can last for a while, but then the surface suddenly changes for the worse. In a real kitchen, corrosion rarely looks like a big orange rust patch on the first day you use the pan. It starts as pinprick pitting, or a slightly rough patch you can feel with a fingertip, or maybe a haze that will not scrub out because it is not actually dirt. Once you have a pit in the metal, you have a place where moisture and salts can hide. So the chemical attack speeds up right where the steel has already failed. People often blame their dishwashers or think they used the wrong sponge, and they just accept the damage as normal wear and tear. Sometimes it really is just wear, but other times it is the result of an alloy you never agreed to buy in the first place. Now, we need to talk about the magnet test. A magnet test mostly separates stainless families like austenitic versus ferritic, but it does not reliably separate 304 from 201 because both can behave as non-magnetic in their normal form. On top of that, a lot of clad cookware uses a magnetic stainless layer on the outside for induction cooking, while the inside surface stays non-magnetic. This means you can get a magnetic pull on the bottom and not on the inside, which tells you almost nothing about the actual grade of the steel. So, if you do not have a laboratory at your disposal, you have to work like a forensic auditor and look for patterns that show cost cutting. First, you should check the weight. All else being equal, ultralight stainless usually means thin stock, and thin stock often travels with other corners being cut because that is how bargain cookware hits a specific price point. You are not necessarily proving it is 201, but you are spotting the kind of product where a substitution is more likely because everything else about the pan screams that it was built to a number. Second, You have to look at the price math. Real multiply cookware with a known corrosion-resistant stainless interior costs real money to make because you are paying for multiple layers and consistent steel. If the price feels like a typo for a full set of pans, you should assume something changed, whether it was the wall thickness, the core thickness, or the quality control. Third, you can try a controlled vinegar soak. You are not doing chemistry theater here, but you are giving the surface a short and consistent acid exposure so you can look at it under angled light. Put a small amount of plain white vinegar in the pan and leave it overnight. Then rinse it and dry it before you inspect the surface. Look for dull patches, a faint speckled pattern, or a rough spot you can feel that was not there before you started. A good stainless interior should look basically the same after a simple test like that, and if it doesn't, you have a problem. If you do not want to play detective every time you shop, buy from brands that publish exactly what stainless grade they use and how the pan is built. Keep your eye on the documentation and the consistency of the brand rather than falling for mystery steel and vague language about premium quality. The real scam here is not that stainless steel is bad, but that the stamp stayed on the pan while the verification disappeared. That 1810 mark looks like a solid promise, but it is just a stamp on the bottom of the pan unless someone actually tests the alloy behind it. If your cookware starts pitting after you use tomato sauce, wine, or a vinegar deglaze, you are not looking at normal wear and tear. This is a deliberate material choice the manufacturer made without your input, and you are the one stuck with the bill. Subscribe if you want more of these teardown audits, and tell me in the comments which brand you bought, where you got it, and if your stainless steel has started staining after you cook with acidic ingredients.